Hello friends, welcome to my YouTube channel. I hope you all are well. In previous videos, we learned about Arduino IDE, Arduino Uno board, digital and analog functions. I hope you watched all the videos. In this video, we will go further with three types of functions that are advanced input and output, time and math. So let's start the video. So in this video, we learn about the three functions. First is advanced input and output, second is time, third is math. So let's discuss each function in brief. First we will discuss about advanced input and output functions. There are 6 types of functions in advanced input and output. First is tone, second is no tone, third is pulse in, fourth is pulse in long, fifth is shift in, sixth is shift out. So first is tone. As you can see on your screen, the syntax of the tone. This function is used to generate a square wave at a particular pin. This produces sound if connected to a speaker. Only one tone is generated at a time if one is running, and we call tone function. It will have not any effect. If the tone is playing on some pin, then it sets its frequency. Tone function also have two syntaxes. As you can see the first syntax, and here is the second syntax. Here the first option of the both functions is pin. You can choose any Arduino pin on which you want to perform this function. Second is frequency. Here you put the value of the frequency in Hertz. And the third option in second function is duration. The duration of tone in milliseconds. This option is optional. If you want to use, you can use. If you don't want to use, you don't need to write this. Next advanced IO function is no tone. Here you can see the syntax of no tone. This function is used to stop the generation of square wave triggered by the tone function. Has no effect if no tone is triggered. Here you can select the pin on which you use tone function. If you want to play different tones, then you need to call no tone once on pin before calling tone on next pin. Next function is pulse in. This function is used as an input function. This reads whether the pulse is high or low. For example, if the pin is high, it waits for a pin to go from low to high, then it starts its timer, then wait for the pin to go low and stop timing, and return the length of the pulse in microseconds and give up and return 0 if no complete pulse was received. This works on pulses from 10 microseconds to 3 minutes in length. There are two types of syntaxes as you can see on your screen. The first syntax, here is the second syntax. Here the first option is pin. You can choose any Arduino pin on which you want to detect the pulse, and here is the value. Either you want to know the duration of high pulse or low pulse. You can select here. In second function there is the function timeout. The number of microseconds to wait for the pulse to start. The second function is faster than the first function. Here is the example of pulse in function. First we declare a variable unsigned long duration, then start with void setup function. Here we initialize the serial port, and here make the pin number 7 as an input pin which we use in pulse in function. Here the void setup is complete. Next is void loop. This loop repeated itself till the controller is running. Here we put the pulse value in the variable duration. As you can see, we use pin number 7 and want to measure high pulse duration. In this function, we serial print the duration time in microseconds. Next is pulse in long. This is similar as pulse in. It can handle long pulses and interrupt effect scenarios. This routine can be used only if interrupts are activated Furthermore, the highest resolution is obtained with large intervals. Other, the function is same as pulsing. Here is also two types of syntaxes. As you can see, first syntax on your screen, and here is the second syntax. First is pin values. Here you put the Arduino pin number. Second is value, that is either high or low, and the timeout used in second syntax. It is in microsecond. Next advanced I/O function is shift-in. This is used to receive data serially. This function can be sent a byte, but one bit at a time. You can choose from which side you want to start sending your bits. It's either left side or right side, or you can say LSB or MSB. First we declare a variable to put the data received in it. In shift-in function, here the data pin on which the data will be received. Here is the clock pin, the pin to toggle to read the signal from the data pin. Here is the bit order. It is either MSB first or LSB first, means on which direction you want to read your data. If you are interfacing with the device which use clock rising edge, you will need to make sure that the clock pin is low before the first call to shift-in. You can also use SPI, but that works on some specified pins, and SPI is faster than this function. Next is shift out. This is used to send the data of 1 byte single bit at a time. As you can see syntax on your screen, here first is the data pin on which pin you want to send the data. Here is the clock signal. Here is the bit order, either it is MSB or LSB. And next is the value which you want to send. If interfacing device is clocked by rising edge, you will need to make sure that the clock pin is low before sending the data. This is all about advanced input and output functions. Now we move on time function. There are 4 types of time functions. First is delay, second is delay microseconds, third is micros, 4 is millis. Here the first function is delay. This function is used in a program to pause the process for the amount of time in milliseconds specified in parameters as 1000 milliseconds is 1 second, as you can see on your screen. Next is delay microseconds. This is also used to pause the program, but for microseconds, as 1000 microsecond is 1 millisecond and 1 million microsecond is 1 second. Here the largest value we can use is 16,383, which creates 3 millisecond delay. Next is micros. This function returns number of microseconds since Arduino board began running the current program. This number will overflow after 70 minutes. For Arduino Uno, its resolution is 4 microseconds. Here you can see the example of micros. First we declare a global variable time. Here is the void setup function. Here we initialize serial monitor with 9600 baud rate. Here the void loop function. Here first we print a string time, and here of 1000 microseconds, so that it took some time to print that value. Next function is millis. This function returns number of milliseconds passed since Arduino board began running the current program. This number will overflow after approximately 15 days. Here is the example of millis function. Here same, we first declare a global variable. In void setup, we initialize the serial monitor with a 9600 baud rate. In void loop, first we print a string name time. Second, put the millis value in a time variable which we defined before void setup. Here we print time value in new line. Here we create a delay of 1 second to slow the process of printing time value. Next are math functions. Here 8 types of math functions. First is ABS, second constraint, third map, 4 max, 5th min, 6th power, 7th SQ, 8th SQRT. Now we will discuss each function in brief. Here the first function is ABS. This means absolute. It is used to calculate the absolute value of a number. In place of x, you can write the number on which you want to perform the operation. This function returns some values as per the below written condition. If x is greater than or equal to 0, this returns x. If x is less than 0, then it returns minus x. There are some notes and warnings you need to keep in your mind while using this function. You cannot use this function as you can see on your screen. Please avoid this. This will give you incorrect results. Use this instead. Keep the other math outside of the function. This will give you accurate result. Next function is constrain. This constrain a number to be within the range. X is the number to constrain, A is the lower end range and B is the upper end range. This function returns a value. It returns x if x is between A and B. It returns A if x is less than A. It returns B if x is greater than B. Here you can see the code which limits the census value between 10 to 150. Here sense value is the type of variable you can declare is unsigned or signed int. Here the sense value we need to constrain between 10, which is the lower end, and the upper end is 150. If the value is less than 10, then it will return the value 10. If the value is greater than 150, then it will return the value 150. This function is used to remap the value from one range to another range. Here the value to be mapped, this is the lower bound of the current range, this is the higher bound of current range, this is the lower bound of target range, this is the higher bound of target range. Let's understand this with an example. Here in word loop, you read an analog value on A0 pin. Here you get the value range between 0 to 123. Here in map function, first we write the value variable, then the values which we receive from the well, that is 0 to 1023, and we need to convert this between 0 to 255 to write in analog function. As you know, at analog write, values rise between 0 to 255. Here you can see from first the value is gone there, then after mapping we write the same value there. Here is the analog read foundation between 0 to 1023. Here the analog write foundation, that is between 0 to 255. Next math function is maximum. This returns the value which is higher. Here x is the first number to compare and y is the second number to compare. And this returns the larger of the two parameters. Means in between x and y, which number is greater, max will return that number. As you can see in example, here we declare an integer a and the comparison is done between 12 and 16. This function put value in a is 16. Here is a second example, we do comparison between 24 and 16, and here in a values goes is 24. There are some notes and warnings you need to keep in your mind while using this function. You cannot use this function as you can see on your display. Avoid this. This will give you incorrect result. You can use this like this and keep other math outside of the function. Here the next function is minimum. This will return minimum value between x and y. Here x is the first number to compare and y is the second number to compare. And this function will return the smaller of the two parameters values. As you can see example on your screen, here first to declare an integer and write the minimum function. Here the two variable values are 12 and 16. Here this function put 12 in a. As you know, 12 is the minimum value. This function put 16 in a. As you know, 16 is the minimum value between these two values. Here are some notes and warnings you need to keep in your mind while using this function. You cannot use this function as you can see on your screen. If you use this type, then this will give you an incorrect result. Use like this. Keep other math outside the function. Here the next function is POW x and y. This is used to calculate the number raised to power. This is useful for generating exponential mapping of values and curves. You can see syntax on your screen. You can also understand this function by the basic math equation. Here the variable x, the number, and y is the power. Now you can see example on your screen. Here the number is 9 and the power is 2. This puts the value in a is 81 as 81 is square of 9. In the second example, 11 is the number and third is its power, and this put in a 1331, that is the cube of 11. Next function is square. You can see syntax on your screen. You can also understand this by basic math equation. Here x is the number and 2 is the power of that number. Here you can see the example. Here we do square of 6, that puts value of 36 in A. In second, 12 square is 144, that will go in A variable. There are also some notes and warning which you need to keep in your mind while using this function. Please avoid this type of writing of syntax. Use other functions outside of square function as you can see on your display. Next is SQRT, that means square root. We can calculate the square root of x with this function. Here is the math equation. Here is the x for the number which square root we want. Here is the example. Here 121 square root is 11. Here 400 square root is 20. So friends, this is all for now. I hope this video is useful for you. Please like and share this video. If you are new to my channel, please subscribe my channel and press the bell icon to get the notifications. Below in description you can find the link of Facebook group, Instagram and Telegram. Please follow these links. Meet you in the next video. Till stay happy, stay healthy. Thank you.